build your VPC and launch a web server, and that is lab 267. So the lab has started already. We started the lab already, and then so this is the scenario. In this lab, you will use the AWS VPC to create your own VPC and add additional components to produce a customized network for a Fortune 100 customer. You will also create security groups for your EC2 instance. You then configure and customize an EC2 instance to run a web server and launch it into the VPC that looks like the following diagram. So this is the AWS cloud, and this is our VPC inside AWS, right? And then we launch a web server in AZ Zone B, right? In availability zone B in a public subnet, right? Um, we also have, so we have two AZs, AZ, AZ1, AZA and AZB, availability zone A and availability zone B. In availability zone A, we have two subnets, public subnet 1 and private subnet 1. In zone B, we have public subnet 2, private subnet 2. So we can see that from this diagram, our web server, which is our instance, will be able to connect to the internet via the internet gateway, right? And then you can see the NAT gateway is in a public subnet. So that is what we'll be doing. We'll create a VPC and then we'll deploy an EC2 instance into that VPC in the public subnet. So let's go on. First of all, let's create our VPC. So we'll go to AWS. We'll click this button to go to AWS. While that is loading, first we'll go and allocate an elastic IP. Okay, we'll go and allocate an elastic IP so that we can attach the elastic IP to our instance, our EC2 instance, right? I think we understand. Remember what I said by elastic IP. When you want to create a static IP for an instance, you so AWS. If you have recently visited any of the services, it will be listed here. Else, simply search it here, VPC. Then it takes you click on it to go to the VPC console. So let's go and allocate an elastic IP. So go to elastic IPs. Where is it? Go to elastic IP. So some of these some of these resource tabs, right? They are also in and other resources. For instance, elastic IPs, you can also find it under EC2, right? You can also security network ACL security group. You can also find it under EC2, right? But in this case, we are getting it from the VPC console. Go to elastic IPs. You can see we don't have any yet. Let's allocate an elastic IP. Okay, and then let's allocate. We are not changing anything yet. We are putting it in this region is the region we are using. Okay, so allocate. So we have allocated an elastic IP. So when we create the instance now, this is the IP that will be allocated to our instance.
So there's a problem. This network was slow, so we couldn't follow that.
So now that we have allocated an elastic IP, let's move on with the lab. So now let's go and create our VPC. So we'll name the VPC lab VPC. We'll create a VPC with private and one public subnet. Basically, we'll create it for one AZ, one availability zone, right? We'll create the VPC with in one availability zone in which it has one private and public subnet. So let's go and do that. We'll go to we can go to let's go to dashboard. We'll create VPC, VPC and more. If you are creating only VPC without subnet, you say VPC only. But because we are creating VPC with subnets,
Okay, VPC and more.
you say VPC and more. The name tag, we'll put it there, lab VPC. So VPC and more, because we are creating VPC with subnets. The name, let's put in the name the lab gave us, which is lab VPC, lab VPC, and then the the lab didn't specify any CIDR. Okay, it only specified for, say the public subnet has a CIDR of 10 dot this, which means that it's okay. So um, let's go ahead to create the public and private subnets. So this is the VPC name. This is the VPC CIDR, before CIDR block. And then for AZ, we have just one AZ. We'll create another AZ later, right? But let's create only one AZ for now, and one public and one private subnet, right? Yes, one availability zone. So the AZ is in, let's choose, let's, because it's one AZ, so let's leave it to remain in 2A, right? And so we have one public, one private subnet. Now let's customize the CIDR block for the public and private subnets so that they won't interact, they won't conflict with what we have here, the IP for the CIDR block, the IP for the VPC. Okay, so the lab says that we should give it this slash 24, but we still need to change something here because the 10.0.0.0 is the same thing as what our VPC is. Our VPC CIDR block is, right? 10.0.0.0. So we need to change something there. And I need you to take note of this. Else you make it will tell you error when you do this thing, right? So over here, instead of 10.0.0, we'll change this to 1. Okay, then we'll leave this other one as it is. Let's leave it on 10.0.128.0 slash. So instead of slash 20, we say slash 24. Let's reduce the number of IPs to 24, which will give us 256. The slash 20 will give us 4,096 IPs, but slash 24 will give us 256 IPs. So we've done that, right? Public subnet, private subnet. Another thing we can do is let's edit the name. We can edit the name here. Like so here, yeah.
That when we change it.
Okay, we'll edit it after we create the instance. After we create the VPC instance. Yeah.
No, please.
So let's continue. We have customized the CIDR block for the subnets, public and the private subnets. I wanted us to change this, but we'll change this when we create the VPC resource. Now, NAT gateway, let's just choose, since we have a private subnet, let's put it in one AZ, right? Since we only have one AZ there. So in one AZ. So to create a NAT gateway in just one AZ, the one we are creating the destiny. And VPC endpoint, none. We don't need VPC endpoint for now. So create VPC. So that starts to create the VPC and the other resources that needs to be created with VPC. So that will take a few minutes. So our VPC has finished creating, and we can see the things that were created, the subnets, the internet gateways, routable, and so on and so forth. So let's click View VPC. This is our VPC. It's loading. Okay, while that is loading, let's go to subnet. Let's edit the name for our subnet. Let's edit it. You know, on when we're creating it, we couldn't edit it, right? So let's edit it for public subnet. Let's edit the name to public subnet one. So these are public subnets, right? Public one US something something subnet. So let's click that pencil button, pencil icon, click it, then paste in what you have there. You see what I did? And then save. Copy for the private also, which is private subnet one.
Which subnet name do you use? Like what?
Number 12. Then click that pencil button and change the name to uh, paste in the this thing. So private subnet one. So public subnet and private subnet now. We've edited the names now. So now let's move on now to create additional subnets. Those additional subnets will be created in the second AZ, the second availability zone, right? So let's go and create public subnet 2 and private subnet 2. So create subnet. We'll choose the VPC ID that we for the VPC that we created earlier, right? Our subnet name is public subnet 2. First one we're creating is public subnet 2. We put in the name, The AZ is what? US was 2B. You know the first one was in 2A, right? The first one was in 2A, right? Hello? Did we notice it? I think I showed you that the first one was in 2A. So let's go ahead to create more subnets. We'll choose our lab VPC ID, which is this. We'll put in the name for our subnet, which is private and public subnet 2. So availability zone, we'll say is in 2B, right? The second AZ, 2B. This IPv4 CIDR block, let's see what the lab gave us. The lab said we should use 10.0.2.24. So let's copy that /24. So put in the CIDR block. When you put it in, it will bring up the same option. You click on it, right? You click on it. The tag has already been put for us, which is this. Since we have put in the name, the tag has already been tagged to the subnet. We can go ahead to do what? Create subnet.
This last one I did, this is very fast.
Fast. So now we've created uh, the subnets, right? The public subnet 2. Let's create private subnet 2 now. So the same thing we did. We just copy the name for the private subnet 2, right? Private subnet 2, the name. We go back again to create subnets. The VPC ID, we choose our lab VPC, right? The subnet, we put in the name, right? Private subnet 2. The availability zone, we choose the second AZ, which is 2B, right? US was 2B, right? Next, we'll go and pick the IPv4 site that the lab gave us, which is 10.0.3.0/24. Copy that and then paste it in that box. Paste. it brings up the this thing again here, right? Click it, scroll down, and then create subnet.
With availability zone where
So let's continue. The next task is to create a route table, right? So let's go and do that. We go to route table, and then we choose the lab VPC as the VPC that we are creating the route table for. This description now is for the old interface, right? But it's a bit different for the new interface. Okay, so just pay attention while I direct you what to do. So we go to, in our VPC console, we go to route table, right? These are the current route table that we have for the private subnet 1 and public subnet route table, right? But let's do something. Let's create, no, sorry. Let's, just a second. Just pay attention. There's something I want to do here. I need you to pay attention. So they said we should, so they are following the old interface for this case now. But see what we will do. Take this name, private route table, right? Taking this name, then go to route table. You can see that currently the two, um, the initial VPC we created route table for the private and public, created private and public route table. But this second subnet that we've created, they don't have a route table. Look, private route table is associated with, is already associated with private subnet 1, but it's not yet associated with private subnet 2. Same thing with this. The the lab VPC route table public is already associated to our public subnet 1, but it's not yet associated to our public subnet 2. So what we want to do now is that we want to associate the two subnets to that route table. You get it? We want to associate the two subnets to, so the two private subnets, we want to associate it with the route table. We want to associate the two private subnets to the private route table. Let's start with the private first. Private route table. Subnet association. Currently, we have just one subnet associated with it. Let's go to edit subnet association. Okay, first of all, wait, before we do that, let's change this name. You know, the lab says that we should uh, give it the name private route table. That's this thing is according to the old interface, but because we have new interface, and the lab the lab instruction is for old interface, but the lab itself is new interface or AWS. So let's edit this name. Let's edit. That's what they say. Let's go to the pencil icon and edit this name to private route table. So for private route table, let's edit the name to private route table. Right? Save. We'll do the same thing for public. We'll do the same thing for public also. Right? Public route table. So let's do the same thing for public route table. Let me change the private to public. Public route table. So we have edited the two names of the route table. So let's now associate. So for our private subnet, we only have one subnet associated with that private route table, which is the private subnet 1, right? Let's now, so when you click subnet association here, you will see the uh, subnets that are associated with that route table, right? In this case, only private subnet 1. So you see a button here that says Edit Subnet Association. Click on it, right? It brings you to something like this. You will see that your private subnet 1 is already, the button is already clicked, right? The button is already marked, right? So what you don't do is just mark for the second, the other uh, subnets, the other private subnet you want to associate with that route table, which is private subnet 2. Okay, then you go ahead to save association. So when you save association now, then you can see that your two subnets, in this case, the two private subnets are now associated with the private route table. Okay, now we can see that for our private route table, we have associated the two private subnets. So let's do the same for our public route table. If we go to subnet association, we can see that we have just one subnet, which is public subnet 1, that's currently associated with that route table. Let's now edit. Let's edit the subnet association. Let's add the public subnet 2 to it, right? And then save association. So now we can see, if we go to subnet association, we can see that the two subnets, right? Even here you can see two subnets are now associated to, the two public subnets are now associated with the public route table, right? And if you want to see the route, pay attention. For the public route table, you can see that the route says that there is a destination of internet, which is 0.0.0/0, and the target is what? IGW, the internet gateway. Because the traffic that will go to the internet will go through the internet gateway, right? The internet gateway, which has already been created when we created the VPC earlier. That's where this internet gateway was created for us. So let's move on. We have created the subnets, and then we have associated the subnets to the route table. Okay. We have associated the, yes. So for yes, the in our case, you can see that for our routes, we already have a route defined for the internet, right? Internet traffic, which is this, and the target is the internet gateway, this, right? For private also, the target will be NAT gateway, right? NAT gateway. That's apart from the, so apart from the this local one that was defined here, you can see that for internet, for traffic, internet traffic, that's for traffic going for trying to reach the internet, the target will be the NAT gateway. You know, it's for resources in private subnet, right? If they want to be able to connect to the internet, it will be through the NAT gateway, right? That's why we have NAT something something here as target. Why that of in the public subnet, it will go through the internet gateway, right? For them to be able to communicate with the internet and reach the internet. So we have already done all these things that I mentioned here, right? So this is what we have now currently in our environment. Two AZs, uh, and we have public and private subnet in each of the AZs. We have internet gateway, and we have the NAT gateway, which is deployed to the public subnet. And we have the route table defined also, just like I just showed you now, right? I just showed you the route table that already defined. So now let's create the VPC security group. We'll take this name from our lab, web security group. Then we'll go to security group, scroll down to security, click security groups, and then create security group. Put in the name we just copied. Then for description, say enable, copy enable HTTP access, putting it in that description, enable HTTP access. Then we choose the lab VPC as our VPC, and then we go to inbound rule. For inbound rule, we are choosing type as HTTP, source anywhere IPv4, and we'll put in a description, which is to permit web requests. So for VPC, we cancel out what we have currently, which is the default VPC, and then we choose our lab VPC. We go to inbound rule, we click add rule. The type is HTTP, right? HTTP. The default port is port 80, and source is anywhere IPv4, which is the internet. Description, we put in a description that says from the lab that lab give of permit web request. It's optional, you mustn't put it. You can go ahead to add more inbound rules if you wish. But for our lab, we don't need to add more inbound rule. Let's just move on. So we'll go and create security group. So next, okay, so now we've created a security group with an inbound rule for HTTP access. Let's go on to the next task, which is to launch a web server instance. So we'll go to EC2, I'll go to launch instances. We'll choose the Amazon Linux 2 AMI. We choose T2 micro instance type. So let's go there and do that. So EC2, when that opens, you scroll down, launch instance. It starts with tag, but we'll come back to tag. Let's put other things first. No, this is according to the old interface. So the AMI is Amazon Linux 2 and T2 micro instance type. So Amazon Linux, choose Amazon Linux 2, right? Amazon Linux, Amazon Linux 2. There's Amazon Linux 2 AMI. There's Amazon Linux 2 LTS with SQL Server, but this is what we're choosing, right? Amazon Linux 2 AMI. The instance type is T2 micro, so it's already there. Let's leave it. Keeper, we're going with the one lab provided for us, which is the VO key. Although in this case, we will not be SSHing, but let's just choose the VO key as our keeper. For network, let's deploy the EC2 instance into our VPC, the VPC we created, right? Which is our network. Eh? So let's do that. Network, let's deploy it into our VPC. This. Our subnet, let's deploy it into, so you can choose any of the subnets, either public or private. But let's just, sorry, you can choose any of the public subnets, either public subnet 1 or 2, right? But in my case, I will just deploy it to the public subnet 1, right? Are we getting it? You can choose any of the public subnets, but in my case, I will choose the public subnet 1. The auto assign IP, let's enable it so that a public IP from our elastic IP we allocated earlier, right? Elastic IP, it will be automatically, a public IP will be uh, allocated to our instance. So next, security group, that's firewall security group. Let's choose an existing security group that we created earlier, right? Click the button, we see web server security group, we choose it, right? Web server security group, the one we created earlier. So next, the storage, configure storage. Eh? Are we following it? The configure storage parts will remain with the default instance store. That is the root volume. We're not adding another volume. We're not adding an EBS volume, right? We're not adding an EBS volume. So let's remain with the default volume. Now pay attention. If you click the advanced details, if you click advanced details, right, you can see other things that you can specify. In our case, we want to specify a user data. A user data is the place where you put in a script that you want you have applications, softwares, packages you want to install automatically when that instance gets created. You want to install it automatically. So what it will do is that when that instance gets created, those things that you have, those commands you have specified in your user data will automatically get run in the instance. So you, instead of you having to SSH into that instance and start carrying out those tasks one after the other, you can just paste them as a bash script in the user data and those things will get executed. So in our case, our user data is this, right? This is our user data, and I will explain what the script is going to do. Let me paste it first. So you paste it in. You can see it's a bin bash script, it's a bash script. First of all, I said where you have this hash means you want to put in a statement. So this is just a statement. This is a statement here because it starts with hash. So it's just the same thing with this. These are not commands that we run. The one that we run are the one that doesn't have hash, right? So this is a statement. Now, the first thing here is the yum install dash y. Dash y means you want to say yes whenever it runs, right? You want to just automatically say yes. So it won't have to ask you for it, right? So we're installing HTTPD. No, I said HTTPD is the Apache web server, right? A short form of writing representing Apache web server, MySQL, and PHP. This is referred to as LAMP stack. Let me write it on the notepad. This is referred to as LAMP, LAMP stack, LAMP stack, right? LAMP stack. So what LAMP stack means is this. It means you want to have the operating system as Linux, the web server running on that operating system, on that system as Apache, the programming language that the M there is MySQL. The MySQL is the database, right? Database where information about on that site. When people enter their let's say they are filling a form, like when you fill a form, the form, what those details will be stored somewhere. So they're usually stored in a database, right? So in that case, our database is MySQL, and then the P there is for PHP. So P is the programming language that application is written in. No, we have different programming language. Ehen. So LAMP stack is like bringing all those things together and giving it to you as a complete package. So some EC2 instance have already been pre-packaged with those uh, those components. They've already been prepackaged. So they have Apache running on it. They have MySQL on it. They have and then the default program used to write the application that is running on that instance is PHP. So you can now edit it with your own page after you purchase that instance. So LAMP stack is L there is L is Linux. Okay. L there is Linux. A there is what? Apache, right? Apache web server. Web server. Server, okay. Web server, okay. The M there is MySQL, which is a database, right? MySQL, which is uh, a database. And the P there is the programming language, PHP. the programming language that the default application is written in. So it means that the application you will be deploying on that instance will be written in PHP, right? So that's a LAMP stack. So uh, this particular, not 24 minutes. Let's move on. So this particular instance, already we know it's a Linux machine, right? And then we are deploying MySQL on it into the machine. We are installing MySQL. We are installing, and I've made mistake here. MySQL. There's a supposed to MySQL. Let me recopy this. Let me recopy and repaste this. Okay, so look at this. We are installing Apache web server, right? And then we are installing MySQL database client, right? And then we are installing PHP. PHP for the programming language. So what we need to install PHP so as to be able to run a PHP programming language on it, right? The default PHP page will show where we can now edit, right? So that is what this is doing. Install Apache, install MySQL, install PHP. Then the next statement there says download lab files. So on this site here, we want to grab this lab app.zip, the zip file. We want to grab it. And I said, we mentioned when we were doing Linux that to grab a file from the internet via the command line, use wget or call, right? Use call or wget, right? So here we are using wget to do what? To grab this file. This is this file we are grabbing. Lab app.zip, right? And it's a zip file, right? It's a zip file, a bundled file, so that it will be easier to download. Now, when we download it, we now want to unzip it. That's why we use unzip here, right? We unzip the file, the lab app.zip, we unzip it, and then we push it to this directory, HTML directory, right? Push it to this directory. That's what we indicated -d, and then we'll specify the directory. Next is to turn on the web server, the Apache web server, Apache web server service. We want to start it. So that's when we use this command. chk config httpd on. We are saying we want to put on the HTTP, the Apache web server service. Next is to do what? To start, right? No, this said HTTP on. You put on. This is a command, right? But this is the command that starts the web server service, right? This is the command. So that is what the bash script is doing, right? That's what the bash script is doing. So now that we have pasted the bash script, let's go ahead to launch our instance. So because it's a very small machine, T2 micro, very small machine, it doesn't take time to quickly create. You can go ahead to view the instance. So it's still in pending mode, pending state. Let's allow it to start running. So you can see it's still in pending. Normally it's supposed to just say running, right? But you can see it's still in pending because those things that were specified. Hello? Those things are specified in the user's list is now downloading them. Okay, there's something I forgot to do, which is the tag, right? I forgot to include the tag. You remember I didn't add the tag. So let me check what the lab says for me to include the tag. For tag, it says web server 1, okay? So let's add the tag web server 1 as the name is web server 1. So let's add the tag here. In this pencil, choose the pencil button and what? Paste in the name. Paste in the name web server 1 and save, right? So our instance has been named, right? It has been named. So now that our instance has been created and is running, we can go ahead to view our instance on the browser. So pick the public IP or the public DNS name, go to your browser and paste it in. You should get your your site. This is the site that we installed. That lab app.zip, that file, it contains some folders. It contains a folder that has these things inside, right? So when we unbundle it and then run it on our Apache web server, so that is what we have, right? This is our site. If you click RDS, you can be able to use this uh, endpoint, this form. Can you be able to use it to access an RDS database, our RDS database instance? Can you use form to access it? Load test. Can you be able to load test? And then this is the default page, right? So that is it. That is it.
You were not following shit.
Wait. So we can see now that we have been able to, we can now view the, so we can now view the site, right? This is the site that they want us to see. So it depends on, depending on the AZ where you deployed your, in my case, I chose AZ1 when I was creating the instance, I chose public subnet 1. Public subnet 1 is in two-way, right? That's why it shows me that this shows me here that is 2A. If I are choosing 2B, if I are choosing public subnet 2, which is a 2B, right, you would have gotten this. So in your case, if you chose public subnet 2, the availability zone to show here, it will be 2, right? To be 2. So that is the end of the lab, and so we have been able to carry out all of this. In this diagram, the instance was deployed to public subnet 2. That's why you can see US West 2B here, right? But in my case, I deployed it to public subnet 1, right? Which is the same thing. So it's the same thing. And that is the end of the lab. So we can go ahead to end the lab now.